Guys, so I decided I was going to break it up into 2 points. So the first one had to do with ratio. And so now what we're going to do is we're going to talk about the molar mass of a compound. So what we're going to do is we're just basically going to find out how we calculate a molar mass of a compound. So here we would need our periodic table, of course. This will help us out. Now I'm going to show you 2 different ways. One way that I do it and another way the book does it. Don't get confused. You can do either one. It really doesn't matter which one you want to do. Okay? So the first one is asking us for the molar mass for the compound K2CrO4. So the first thing I do is I write down all of my elements. I write down all my subscripts. And then the next thing I'm going to do is I'm going to look on my periodic table and I'm going to say, all right, so I need to find K. K has 39.10, right, grams. CR, well, CR is here and it's got 52 grams. And then O for oxygen has 16. So I've wrote all that down, and now what I'm going to do is I just need to multiply it across. So I'm going to do 2 times 39.10, excuse me, get my answer, and I wrote it down. And then 1 times 52, and I write it down. Then 4 times 16, and then I write it down. And then what I'm going to do is I'm going to take my 64 plus my 52 plus my 78.20, and then I get a total molar mass of 194.20. That's all you have to do for molar mass, okay? You're just going through, it's telling you in the compound how many there is on the subscript, and then you take the AMU from your periodic table, and then you find the math. So, NaOH, well, Na has 22.99, O has 16, and then H has 1.01. Don't get confused with the right side. You're looking on the left side, you're looking for AMU. So then you're going to do 22.99 times 1. Oh, that's 22.99. 1 times 16. Well, of course, that's 16. 1 times 1.01, well, that's 1.01. So then I'm going to take my second answer plus 16 plus 22.99, and I should get 40 grams per mole of NaOH. Now, over here, we also did Ca, Cl2, KClH3O, and then C2H5OH. So these were just the same way, except if you look, this one here, and guys, I'm sorry I wrote in green pen. I'll never do it again. So this here, we have 1 carbon, 1 K, 2 C's, 3 H's, and 2 H's. 2 O's, okay? 1 mole of K. And then what I'm doing here is I'm putting it in a fraction form where I'm doing 39, and I'm doing the same thing as I did over here, except I'm including the 1 mole in that. Okay? Oh, what has happened to my thing has zoomed out. I don't know what I have done to my camera. Okay, sorry guys. I think I hit something over here. So, let me show you how to do that. So what you're going to do is you're going to do 1, open bracket, alpha y, enter, 39.10 over 1. Now, where did I get the 39.10? I got it from my K, which is right here. Okay, guys? And then I'm going to close my bracket, and that's going to give me 39.10. Carbon, I have 2. So I'm going to do 2, open bracket. Well, carbon is 12.01. So I'm going to do alpha y, enter, 12.01, down 1 over close bracket, and then I got 2402. Hydrogen, 3, open bracket. I know it's 1.01. 1.01 over 1 gives me 3.03. And then 2, open bracket, well, oxygen, 16, alpha y, enter, 16, 0.00 over 1, close bracket, and that gives me 32. So then I'm going to take my 32 plus my 3.03 plus my 24.02 plus 39.10, and I'm going to hit enter, and that gives me my 98.15. Okay? Do not be intimidated with these. Only thing that you're doing is you're taking them, breaking them down into from a compound to an element. You're looking on the periodic table to find out what the AMU is. You're multiplying it by the subscript, and then you're giving a total. Now let's look at 35. 35, I have C2H5OH. Okay? Now, this is a little tricky because there's 2 hydrogens here. Okay? So I have carbon, I have 2. Hydrogen, I have 5 plus 1, where I got my 6 at. I just combined them. They're both hydrogen. It doesn't matter if it's together or not. And then our oxygen, 1. And I did the same thing as I did before, and I got 46.08. Let's look at the other page. The other page, here we go again. We have HCN, hydrogen, chlorine, and nitrogen. They're all 1s. Add them together, 2703. CCl4, well, that's carbon and chlorine. Do my little math, and I get that done. And the last thing that it's doing is it's just basically taking what you've learned at the beginning and telling you, after you find what your moles are, you can also change that to grams, or you can convert your mass of your compound to molecular or molecule. But over here is a main idea thing. Now, in this main idea, I'm going to zoom in. In this main idea, what this is basically is a roadmap. So if you're taking mass of a compound and you're trying to get to a mole, this is what we're using. If you have a mole and you want to make it to a mass of a compound, that's what you're going to do. You're trying to find grams here, right guys? Grams is over here. So I'm going to go ahead and add on mine to make sure I understand. This is the way I find grams. Well, over here, this is a way that I'm going to be able to find particles. Up here, this is where I'm going to be able to find mole of an ion or an ionic. So what I'm trying to find here is I'm just trying to find moles up here. Okay, so I'm going to put moles up here. Moles, grams, and molecules. Got it? So, what you're going to be doing next is you're going to be doing a handout. And in that handout, so what you're going to do here is you're going to start right here. And so it tells you, what is the mass of 2.7 moles of CO2? Well, you have choices of 77, 120, 121, or 16. So you'll need to do the math problem with that. And depending on where you go is what you do. So in this maze, when you get done, you should have a certain one colored. Okay? So if you don't do it right, I want you to try to see what you can do. I'm going to try to have this colored for you and put up for you on Sunday so you can look at it. And I hope you have a good day.